Hey mathematics learners, welcome to Distance Learning with Lee, where I make learning mathematics super easy. On today's video tutorial, guys, we are still going through the grade 12 June 2022 paper 1 that was written by the Gauteng province learners. And in today's video tutorial, guys, we are going to be going through question 6, and question 6 basically deals with financial mathematics. Question 6.1, guys, we are going to be using the straight line method to help us calculate the value of the n, right? In question 6.2, we are going to be using the reducing balance method to help us calculate the value of our unknown variable a, right? Our future value, right? And in question 6.3, we are going to be using the knowledge that we have when it comes to timelines, when it comes to compound interest, right? When it comes to what you need to do to the value of the I if we are told that this investment is compounded monthly, right? What do you need to do to that I, right, that you are given? If you're told that the investment is compounded monthly, what do you need to do to the value of the n, right? So if you struggle with those concepts, please make sure that you watch this entire video tutorial because it's going to be super informative, right? Before we get started with the video tutorial, please make sure that you are subscribed to the channel. Please make sure that you click on that notification bell so that you do not miss a single video tutorial when it drops, right? Because you guys are basically preparing for your finals, I will be uploading video tutorials back to back. So please make sure that you have clicked on that notification bell, guys. And also don't forget to share the channel with your friends, all right? So guys, without any further ado, let's get started with today's video tutorial. Right, so let us have a look at question 6.1. It says that how long must 50,000 be invested in order for it to double at an interest rate of 8.5% per annum on the straight line method, right? So the first thing that we basically need to be aware of in this question is that we are going to be using the straight line method. So what is the straight line method? If you have a look at your formula sheet, the straight line method formula is the same formula that you basically use simple interest formula. So the straight line method is the simple interest formula, right? So let's have a look at the variables that we are basically given in this question, right? We are told that 50,000 is invested, right? You take 50,000 and you invest it into an account. So what does that mean? It means that presently, right, you are putting 50,000 into your account, okay, right? And then they tell us that this 50,000, you want it to basically double, right? Meaning that you want the accumulated amount that you get at the end of how many years that you leave it in for to double, right? So that means that you want the A value to be double, right? The 50,000. So 50,000 times 2, guys, is 100,000, okay? And then we're told that, okay, this investment, the interest rate is 8.5% per annum, right? So the interest rate is 8.5%. So in other words, if you take 8.5 and you divide it by 100, what do you get? You get 0.085. So that is the value of our I. Okay, right? And then what are you actually looking for, right? So you're looking for the value of n. How long must this 50,000 be left in that investment account for it to double A, that's the value of A, at an interest rate of 8.5%, right? So that is what we're looking for. We use the straight line method. The straight line method is A, which is equal to P 1 plus I multiplied by n. Okay, at this point, guys, it's very simple. You substitute all these values and you basically make n the subject of the formula. In other words, you isolate n so that it's on its own, and then you find out what that value is, right? So that is exactly what we're going to be doing. So A is equal to 100,000, okay? The P is equal to the 50,000, okay? 1 plus the I is the 8.5%, which is 0.085 multiplied by your n, which is what you're looking for. Okay, so we're going to try and now solve for your n. Okay, make n the subject of your formula. We're going to start off by dividing by 50,000. Okay, so if you divide by 50,000, you get 2, which is equal to 1 plus 0.85 multiplied by n is 0.085 n. Okay, this is the same as saying 2, which is equal to 1 plus 0.085 n. Then you take the 1 to the other side, so it's 2 minus 1, which is equal to 0.085 n. And if you divide by 0.085, what you do on the right-hand side, you need to do on the left-hand side. Okay, you'll find that your n is equal to 11.7647, and it goes on and on and on. So that is the value of our n. But then they say that you need to give your answers in years and months, right? So what does this mean? It means that we've got 11 years, right? Because our answer is n, which is equal to 11.7647, right? Okay, but we want it to be in years and in months, right? So we know that, okay, that is already the years. So it's 11 years, right? And then how do we convert that 0.7647 into months, okay? How do you convert that, guys? We know that 1 year is equal to 12 months, okay? 1 year is equal to 12 months, right? Okay, so that's 0.7647 is still in years. You want to convert that to basically months. So you're going to multiply by what you want, which is 12 months, and you divide it by what you already have. This is already in years, right? Okay, so 0.7647 multiplied by 12 months, what do you get? You get 9.1764 months. Okay, right. So in total, how long then must this 50,000 be invested? It needs to be invested for 11 years and 9 months. Right. Happiness. Let's go into the next question. A cell phone valued at 24,000 depreciates, right, at 18% per annum on the reducing balance method. Determine the value of the cell phone for 3 years, right? So in this question, we are basically given a cell phone, right? And we are told that this cell phone depreciates in value at an interest rate of 18% per annum, right, on a reducing balance method. Right. So the first thing that we basically need to be aware of here is that we are going to be using the reducing balance method. Right. And the second thing that we are going to be aware of here is that we are basically working with depreciation. So something is depreciating in value. Right. So what is the reducing balance method that we know of? Right. So the reducing balance method, guys, is A, which is equal to P 1 minus I to the power of n. That is the reducing balance formula that we basically use, right? And we are told that because it depreciates, guys, you need to be aware of that. That needs to be a negative there, right? Because it's depreciating in value, right? Okay. And then we are told that the initial or the present value of our cell phone is equal to 24,000. So our P is equal to 24,000, right? Our I is equal to 18%, right? So we know that it's going to be that 18 divided by 100, which is going to be 0.18. We are told that the value of the cell phone, you want to find out how much the cell phone will depreciate by in 3 years, right? So the N is equal to 3, okay? And then we are looking for what? The A, or what the future value of the cell phone will be if it depreciates by 18% for 3 years, okay? Okay, we want to find out what the future value is. So this can also be future value, which is equal to your present value 1 minus I to the power of n. You can also write that formula like that, right? So we want to find out what the future value of the cell phone will be if it depreciates at an interest rate of 0.18 for 3 years. So we're going to substitute all those values into our formula and we are going to solve for our A or our FE. Right, that is what we looking for, right? So what is the present value of the cell phone? We said that it is 24,001 minus. What is the value of our I? It's 0.18. And then what is our N, which is 3 years, right? Simply punch all of those values into your calculator, okay? You'll find that you get 13232.83 cents, right? So if you round it off to 2 decimal places, that is going to be your final answer. So the value of the cell phone after 3 years will be 13,232 rand and 83 cents. So that cell phone has basically depreciated by how much? 10,767 rand and 17 cents. That is a lot. Okay, so right, the value of this cell phone in 3 years time will be 13,232 rand and 83 cents. Okay, so let's move on to the next question. Okay, question 6.3. We are told that X rands is invested into an account at an interest rate of 12% per annum, compounded monthly. We are told that 3 years later, 2x rands is deposited into the same account, and we're told that after 7 years, right? Okay, there is 276,558.75 in the account. We need to determine how much money was invested at the beginning, right? So like I mentioned with this question, guys, we need to basically use timelines to help us understand what is actually going on here, right? And another thing that we need to basically decide on before we even get started is that what formula are we going to use? Are we going to use the compound interest formula? Are we going to use a simple interest formula, right? In this case, because money is being invested and it accumulates interest, you need to remember that we are basically going to be using the compound interest formula, right? So the formula A, which is equal to P 1 plus I to the power of n is the formula that we're going to be using. We're not going to be using future value formula because we are not putting equal installments into an account, into a savings account so that it accumulates. No, we're not going to use the present value formula because it's not a loan that we pay or a bond that we're paying up with equal monthly installments. So we're not going to use the present value formula. We're not going to use the simple interest formula. Definitely not, right? But we're going to be using the compound interest formula because we are basically saving money and it's accumulating what? Interest. So that's what we're going to be aware of. Secondly, guys, like I mentioned, we are going to be using timelines to help us answer this question, right? So this money, right, is invested into the account for how many years? 7 years. So we're going to have T0, 1, 2, 3, 4, 5, 6, 7. Okay, right? And then let's basically put in all the variables that are given to us. Okay, we're told that X amount of rands is deposited into our accounts, right, initially. And then we are told that after 3 years, so 1, 2, 3, right, we put 2x into the account, right? We're told that this account basically generates an interest of 12% that is compounded monthly. So what does it mean if they say that it's compounded monthly? It means that the value of your I, right, is going to be the 12% divided by 100. So 12% divided by 100 is equal to 0.12. Okay, and because it's compounded monthly, what do you need to do? You need to divide by 12. If it's compounded quarterly, you just take the interest, 0.12, and you divide it by 4. If it's quarterly, right? If it's compounded semi-annually, right, or half yearly, it's going to be 0.12, and you divide it by 2. Okay, and then what happens to the value of your n, right? If it's compounded monthly, whatever the value of your n is, you're going to multiply it by 12. If it's compounded quarterly, whatever the value of your n is, you're going to multiply it by 4. If it's compounded half yearly, whatever the value of your n is, right, you're going to multiply it by 2, right? So you need to be aware of those finer details when you are dealing with these financial mathematics questions, right? But then in this particular question, guys, just take note that we are told that it's compounded monthly. So we know that, okay, your I, it's going to be the interest rate divided by 12. And then the N is just going to be the value of the N, or the years, right, multiplied by your 12, or the period multiplied by 12, right? So let's get started with now solving this question. So here we've got two amounts. We've got an amount that is initially deposited, and then after 3 years, we've got another amount that is initially another amount that is deposited, right? So we're gonna take this amount that we put into this account. It's going to accumulate interest, because for how many years? For 7 years, because it's going to stay in our account for 7 years. So the X that is initially deposited is going to accumulate interest for 1, 2, 3, 4, 5, 6, 7 years, because it stays in our account for 7 years, right? So let's just do that, okay? So we're going to we know that A is equal to P 1 plus I to the power of N, right? Let's start off with the first principal value, or value that is initially deposited into our account. And we know that the amount that is initially deposited into our account is X rands, right? So that is X, okay? 1 plus, what is the I, right? For this X rands that is deposited, our I stays the same or remains constant throughout the period. So it's going to be the 0.12 divided by 12. And what is our N? This X rand stays in our account for how many years? 1, 2, 3, 4, 5, 6, 7, right? So the N that we substitute there is 7 years multiplied by what? 12, because it's compounded monthly, plus, then there's something that happens here, right? We've got 2x now that is also deposited into this account, right? And it's deposited in our year 3, okay? And this 2x stays in our account for how many years? 1, 2, 3, 4 years, right? Okay, so the P in this case is 2x. 1 plus our I in this case is 0.12 divided by 12. And then our N in this case is 1, 2, 3, 4. 4 multiplied by 12, right? Okay, so please don't get lost. We are basically using the compound interest formula twice in this case, because we've got money that comes in and we've got money that comes in, right? And we basically need to take note of, right, the different periods that these deposits that are being made stays in the account, right? So that is why we've basically done this use this compound interest formula twice, right? And then here, what do we also know about the value of our A? We told that the accumulated amount is 276,558.75 cents, right? So from this point, we've basically solved or substituted all our variables. All we need to do now is we basically need to what? Determine how much money that is the value of X that was initially deposited, or what is the value of the X, right? So what do we do here, guys? We can just simply solve these individually, right? Or you can just take out a common factor of X, right? So if you take out a common factor of X, what are you left with? 1 plus 0.12 over 12. 7 times 12 is 84, plus if you take out the X, you'll be left with 2. 1 plus 0.12 over 12, and then 4 times 12 is 48, okay? And then you're just gonna punch this into your calculator. If you punch it into your calculator, you're gonna get 5.531, and then this just stays as 276,558.75. And if you divide by 5.531, we divide by 5.531, you'll see that X is equal to 50,001.58, right? So that is the amount that is initially deposited into your account, right? That is the value of our X here. The value of our X is 50,001 rand and 58 cents, right? And then that 2x that was deposited in the third year, you're just going to take the 2 multiplied by that 50,000. That means that that amount is 100,003.16. So that was the amount that is deposited in our third year. For this question, what you guys need to remember is that you have to basically use the compound interest formula. Secondly, in this question is that you need to remember that you have to use timelines, because if you don't use timelines, you are not going to realize, okay, that this X actually stays in our account for how many years? 7 years. This 2X stays in our account for how many years? 4 years, right? So using a timeline, or yes, a timeline, it helps you take note of that, right? Another thing that you guys need to remember here, if it's compounded monthly, it's the value of your interest divided by 12 and the value of the n multiplied by the 12. And in this case, we had two different n's because the first one stayed in the timeline for 7 years. The second one stayed in the timeline for 4 years. So you need to take note of that, and please don't make unnecessary mistakes. This question is out of 6 marks. This was a nice paper. This was a nice question, right? They were not killing people with these questions, right? So please make sure that you practice more of these questions, right? And you take notes. When can I use the compound interest formula? When can I use the simple interest formula? When can I use the present value annuities formula, future value annuities formula, right? Am I taking out, is it a bond where I'm paying monthly repayments? Right? Am I saving for my child's future education by putting 50 Rand every month into an account? Is it future value? Right? So take note of those finer details. Okay, and then if you do that, you should be fine. If it's compounded semi-annually, you just multiply it by 2 for the value of your n, and you divide by 2, your I divided by 2. If it's compounded quarterly, for the value of your n, you take the value of your n, you multiply it by 4, and for your value of your I, you divide by 4, right? But I'm going to do more tutorials on that so that you guys are aware of that too. I hope this video tutorial was super informative, super helpful, and I'll see you guys on my next upload, guys. We're doing question 7 and it deals with calculus, right? See you guys on my next upload. That is it, guys, and I'll see you guys on my next upload, Distance Learning with Lee, where I make learning mathematics super easy. Bye, guys.